Okay, we are live.
I guess we are live.
Okay.
Just let me streaming start on the open. Also ready. Stop it. Sir, आ गए गौतम सर आ गए ठीक है ऑल द बेस्ट गाइस इसकी मेरे चैनल पे देखते हैं I think we are connected. Gautam sir is here. Sir, are you able to hear us? Gautam sir, are you audible?
Yes, but you're breaking off. Your audio is breaking off.
Just put it over.
I can see you well. I can see all of you well. And if someone else talk, maybe your audio is breaking off. Maybe if someone else talk, I will find out. Can you hear me well?
Yes, sir, we can hear you well, sir, but we are not able to see you. Yes, sir, now we are able to see.
Okay.
Ekta or Kushal, say something so that we can make sure that the voice is.
Is my audio clear? I think my
Yes,
audio
very
is clear.
Yes, Kushal, your audio is very clear. I can hear you very well.
Tishan, can
Thank
you
you, sir.
just
Hello,
say
sir. How are you?
I'm doing good. How are you?
Oh, excited.
Ekta,
Same
Ekta,
here.
Very
can you?
excited.
Hello, sir. How are you?
I'm doing good, Ekta.
Welcome, sir.
Thank you.
Welcome, sir. And am I audible to you, sir? My voice
Yeah, I
is...
can hear you now. You know, your audio is not as good as, I'm not talking about the quality of your audio. You speak very well. I'm talking about the electronic part. They, Ekta, Kushal, Teshan, they were a little bit more clear. Maybe you have the bandwidth issue, but now I can understand. So that's fine.
Okay, sir, so we are live here. So we'll just check on the YouTube that we are live. It's working fine.
It's showing live.
Yeah, I think we will see that.
So yeah, I'm going to feedback the. Okay, just a second.
Rupesh, it says that we are live on YouTube, so we could continue.
Yeah. Okay. Thank you so much for joining us, guys. This is Rupesh Mahore, President of Planck Physics Society and IIT Rotterdam. And today we have with us Dr. Goutam Chattopadhyay with us. Dr. Chattopadhyay is a senior scientist at NASA Jet Propulsion Laboratory and a visiting professor at California Institute of Technology, Caltech. The topic of today's webinar is career in space technology. Career in space technology and science. So we welcome you, sir, and thank you so much for giving your time to us. And first of all, the first thing that I'd like to say is whenever we are having a guest, someone like you, the most important thing is it is not that we only learn new things. It is also that we also unlearn some preconceived notions and a perspective shift is there. So, sir, I'd like to welcome you from my physics society and my college. So, thank you so much, sir.
Thank you very much. I hope you won't have to unlearn much because you are all very learned people already. So that won't be my aim here. I want to talk to you about my experience and what I think is a the technologies and the innovations that is needed, because yesterday was 5th of September, the Teachers' Day in India.
Yes.
And I want to wish all of you a very happy Teachers' Day, one day late. The reason is, for me, that we are always a student. We always learn. So whatever you do in your life, you'll realize that your student days are not over. So it will be there with you all the time. We keep learning. And so generally, as a teacher, I also teach, right? So I am a student as well as a teacher at the same time. So in that way, I learn from students as much as the students learn from me. So that's why for Teachers' Day, I think it is a combination of both students and teachers. So I want to wish the students as well as the teachers a very, very, very happy Teachers' Day. I'm very excited to be here. I want to really thank Rupesh because he contacted me on LinkedIn, and he didn't give up. He he kept on, writing to me, because I had little bit conflict and scheduling problem, because since the COVID-19, this webinar thing became a big all around the globe. And I am getting invitations from everywhere, 5 or 6 seminars a day. I cannot do that. So as a result, I had to postpone it a little bit. But I'm really happy, because I always like talking to students and young professionals, because you are our future. And as I said, I learn as much as you learn from me. So I'm looking forward to interacting with you all. Whatever limited knowledge I have, that not that I have answers to all the questions, no one has, but at least through these discussions, through interacting with each other, that's how we learn, that's how we progress. So I'm looking forward to this event. Thank you very much.
Thank you so much, sir. That was a really nice introduction to our addressing to us. So talking about career in space science and technology and innovation out there. First of all, I would like to know about your journey. I know I have heard and I have learned about you that you belong to somewhere near Kolkata, and the journey from the place like Kolkata, some outskirts of Kolkata to NASA. It is really inspiring. So first of all, I'd like to know that where was the point in your early life which actually triggered you or made you believe that you should pursue a career in space technology or something?
Yeah, that's a very good question. So I'll tell you my life journey a little bit, so that you will get an idea that, when I decided that this is my, calling. So as when you study undergraduate, it's very difficult to know exactly what you will end up doing. You'll find that many people, we don't really know, because, even if someone says, oh, I know exactly I want to do this, but it's not really clear, because we are growing, we are learning, and then our path can take, you might find something very interesting and you go in that direction, or sometimes you are constrained by your circumstances, right? So that even if you want to go for a higher studies, but maybe you cannot go, you have to take up a job because of some financial constraints you have. So we go through all these. So for me, I grew up in a small village called Novogram. So that's why I call my journey from Novogram to NASA. So this is outskirts of Kolkata, about 15 kilometers from Howrah. That's, but that area was not very developed. And I come from a very modest, economic background. Modest is a very, good word. I actually come from a very poor economic background, let me say that way. So my father, we are 6 brothers and sisters. So I have 4 sisters and I have another brother, and 6 of us, but we grew up in a 1-bedroom home. So 1 room, it was 14 feet by 12 feet. I know exactly. And there we did not have cement on the floor. The floor was mud and the brick wall and asbestos roof. That's all we had. And sometimes we did not even get to full meal a day. So, I used to go to bed hungry in the night. And then if you are hungry as a kid, then you cannot fall asleep. So I used to, remain awake and dream. When one thing that doesn't cost anything for anyone is to dream, right? You can dream, and I used to dream big. I used to think myself, we did not have the newspaper never came to our home because we could not afford. So, but there was a club nearby. So my brother and I every morning we used to wake up and go to that club where they used to deliver newspaper before anyone can actually pick it up. We used to stand there and read from first word to the last word of the newspaper. And there I used to read all those kind of stuff that I once read that Jayant Nalikar is a very renowned physicist in India, Professor Jayant Vishnu Nalikar. So he came to Calcutta to give a talk. I was so excited. And then I used to read that Richard Feynman, a very renowned physicist from California Institute of Technology. So he's given a talk and all this. So I used to then dream lying in my bed about those aspects that, I am in NASA, space, because space science actually inspires a lot of people. You look up in the sky and you see the moon, you see the stars, and you think, from where all these things are coming from, so that is always an exciting thing. And reading in the newspaper, it used to excite me, and I used to dream, and I used to kind of put myself in that scenario that I am in NASA or I am at Caltech, and I'm interacting with all these people, and it used to feel good, So that used to happen. But my mother and my parents used always to tell us that people like us, I know my story is not an isolated story, because it is the lot of people in India and across the globe, they are in the very similar circumstances. And so a majority of the people, they have very modest means. So I can connect with them very well. My mother is to tell us that, for people like us, the best way forward is to work hard, study well, because education is the only way out of poverty for many people. So all of us did. And actually, my brother and I both went to engineering college. So to the second oldest engineering college in India, called Bengal Engineering College. It is now called
IIS.
IIET.
Yeah, IIS.
Yeah, IIES is the rename. So I went there. That is the oldest engineering college in India, according to, there is some kind of controversy, but Roorkee is the oldest engineering college. And then the Gindi in South as well is very close to all this. So I went there. Then after my I completed my undergraduate in electronic engineering. I had to take up a job, and because I said our financial situation is such that I needed to take up a job. And I saw once in the newspaper a small advertisement for a job opening in TIFR, Tata Institute of Fundamental Research. I knew about TIFR because Jayant Nalikar was at TIFR.
Yes.
And then I applied without knowing anything about that job. I applied and I got a call for an interview. I went there and I got lucky that they selected me. And so they were building a radio telescope called GMRT, Giant Meter Wave Radio Telescope. So many of you know that actually. And there was Professor Govind Swarup, a very famous astronomer. He came back to India from US, Stanford University he was at, because Homi Jahangir Bhabha asked him to go back to India and start the radio astronomy. So he was building that telescope. So I joined, and actually there I met Jayant Nalikar. Think about it. You dream about all these people, and guess who I meet there? Jayant Nalikar, Govind Swarup, and my eyes opened. That was the first time I actually started realizing what physics, what astrophysicists actually they do. And it's a very open environment there. I can go and talk to anyone anytime. And that makes you, very confident in that way. Because I learned my medium was Bengali medium. I have been living in the United States for the last 25 years, but still I have thick Bengali accent, you can realize. So I studied in Bengali up till 10th grade. And then for the first time when I started talking in English, because even when in college, everyone is talking Bengali, when I went to TIFR. So, so always if you are a little bit, not very conversant in speaking English, you feel a little bit uncomfortable. You feel a little bit, your confidence level is not that high. But TIFR opened that up for me, and I had really good experience there. I built some system there that is being used now. And then always there's a bee in my bonnet that I need to do higher studies. So I applied. I actually got admission to do masters in India as well, in Indian Institute of Science, Bangalore and IIT Kharagpur. But I came to US. I first came to Virginia, University of Virginia. And there I did my masters. And then I told you that I had this fascination about Caltech, MIT and all those places. So I told my master's thesis advisor that I'll apply to 3 places for my PhD. If I get admission there, I'll go there. If I don't get, then I'll stay back and work for my PhD with him. And he was very open about it. And I applied to 3 places. That was Caltech, MIT, and UC Berkeley. And to my utter surprise, I was very lucky. I got admission to all these places. And then I went to my thesis advisor, master's thesis advisor, where should I go? And it turns out that he did his PhD from Caltech. So he said, of course, you should go to Caltech. And I came to Caltech. Caltech is a very small university. Many of you don't know California. Only 2,000 students are there, but it's a big name. It has been ranked #1 university in the world many, many times. Even now, just it switches one spot here and there. And there are Caltech produced 42 Nobel laureates in all different subjects. And when I used to walk around at Caltech, I used to see someone walking by me, he's a Nobel laureate. And I used to think, am I still dreaming those dreams, at home as a kid, or is real? So I used to pinch myself. And it turns out that, although I was doing my PhD in electrical engineering, my thesis advisor was in physics. And the physics building where I used to sit every winter, guess who used to come there? Stephen Hawking. And he used to sit only 2-3 doors from my office. And I used to see him, I used to talk to him. And again, sometimes you dream about some stuff and it becomes reality. And so maybe if you want something really bad, then it happens. And of course, you have to work for it. There is no miracle really, but you have to work for it and it happens. And there other physicists used to come and talk to Stephen Hawking, like Kip Thorne. Many of you might know that 2017, the physics Nobel Prize for the gravitational waves went to Kip Thorne. So Kip Thorne used to come. So I came to know about all these big names, and they are so simple and humble. And through my life, one thing I realized, many of you might realize as well, that more you know, more you realize how less you know. So that is one of the lessons of life that I feel every time I'm learning something new and say, oh my God, so less I know. So then I was finishing up my PhD. Then one day I got a call from NASA saying that they have they know about me, they have read my papers and everything that I've been working on, and they want me to go and give a talk to there, and if I'm interested in joining them. Luckily, there was no video phone at that time. Otherwise, they have seen that I'm jumping up and down. So I said, of course. I said, of course. And there I went there. When they hire here, they do. It's very different. It's not that they will ask you to go to the board and solve an equation or something like that. Because I gave a talk and I met the whole day on different people and talk to them. So they try to find out how you think, or how you interact with people, because the problems that we solve nowadays are too complex to solve by yourself. So you'll have to work in a team. The teamwork is very, very important. I tell everyone, and all of you also, that you should always work in a team, and also go out for coffee, go out for tea with your friends, and not only the friends who work in your area. Go out with friends of all different backgrounds, because if you are getting input from everyone, your life enriches. You actually learn much more. Like every day at 3 o'clock, you can see my background is that I'm actually not sitting in front of that.
Yeah,
the background that is the entrance to NASA JPL. Just beyond that, there is open area. When we go inside, there's a coffee cart, and every day at 3 p.m. you'll find me drinking coffee with a bunch of young people, my postdocs, and they're from all different areas. We discuss about so many different things. We discuss about soccer, we discuss about politics, we discuss about science, sometimes about work as well. And there, actually, we came up with so many new ideas that quite a few of my patents came from the discussion that we had during the coffee with people on different backgrounds. Because if you are, sometimes we get corrupted in our knowledge, in the sense that we think in a certain way because I know what is possible, what is not possible, because my experience, my knowledge gives you that. However, if someone else comes in who is not in that background, they think very differently, right? So when we talk to them and they will say, okay, you can try this way. And I think, oh, I didn't think about that, because I am focused in a kind of tunnel vision that you can get sometimes. So it's very important that you go out and talk to people of different backgrounds. And as I was saying, that I actually love every moment of my life that I'm living now. I'm living my dream. And it never happens that Monday morning you wake up and I feel, oh, today I have to go to work again. No, I am excited to go back to work because we are doing so many exciting things. So that's my journey. That's how I actually came to work at this place that you can see in my background.
First of all, the people that you have mentioned, it's like including Professor Jayant Alikar and Kip Thorne and Stephen Hawking. It is for me, it is like really hard to process it even. So in fact, we have especially in our physics department, we have like idolized Professor Nalikar. And I actually have a photo of Professor Nalikar in my hostel. So I'd like to know a little bit about his character sketch in your terms, like how he is as a person and as a lecturer and science.
Yeah, Jayant Nalikar is an amazing person. Many people, you don't know what Jayant Nalikar has done, really done. If he has done in physics, in astrophysics, he has done fundamental work. That most of us, we know about this, his theory of steady state theory that he has done. He has worked with when he was a graduate student. However, he has done actually contributed in a very fundamental way in many different areas. And then he comes here to Caltech very often. Actually, when he comes, I know him personally very well. Actually, my wife is from Pune, Maharashtra. She is a scientist herself. She is an environmental scientist, and Jayant Nalikar actually taught her physics, electrodynamics, when she was doing her master's in physics in Pune University. Professor Nalikar was at that time in TIFR Bombay, but he used to come to Pune University and teach physics. So, and then when he comes here, he actually came to our home as well. We know him well. So it is, so work-wise, if you think about it, he was giving a talk last time he came here, and he giving a talk about, what he was working on when he used to come from, UK to Caltech, and he used to talk to Feynman, and, they're discussing all these different things. So sometimes we actually forget our own, that history or the contributions that a lot of scientists that has made. Jayant Nalikar is one of them. Another person is Professor Govind Swarup. And I also came.
He's the father of.
Yeah, he actually the father of radio astronomy in India. The UT radio telescope and then GMRT he did. I mean, it's amazing. He's now 90 plus. Govind Swarup, and even if you go and talk to him, he is a kid inside. He is excited all the time. He's bubbling with ideas, and I don't know whether I'll be able to be like him when I'm 90, because he's so much of energy. That's what it does. And also they are people like if someone knows a lot, they are very humble. So that is one of the things that I have learned meeting with all these great names, that they know so much, but they never show off. So Well, my advice to all of you, before you sometimes ego takes over, we actually think we know everything. You should think about those people because they won't have to show off because we all know they are great
They
people.
already
So
know
I
that.
have so much respect for Nalika and, Govind Swarup and all, they are real, not only great scientists, they're great human beings. That is very important aspect that you should all remember, that at the end of the day you have to be a very good human being as well, and they are the living example of that.
So, starting from your undergrad studies, I would like to know a little bit about it. So, like your undergrad studies and then your work at TIFR, what exactly that was?
So, an undergraduate, as I said, it's very difficult. You don't know what is your calling because what exactly. So, I sometimes they find a very good professor who is teaching one particular subject, and then you get hooked to that. So, for me, the digital signal processing was one of the subjects. That I started liking. But there was a professor who was teaching very good microwave engineering as well. So I actually started liking to microwave. But the when you are learning microwave, you have to do all this, vector algebra because electromagnetics. I know a lot of
Electromagnetic.
students, they run away when they start seeing that curl and divergence. But that is electromagnetics. But again, you'll have to teach students in a way that they find it interesting. If you on the very first day, if you go to the class and start writing these Maxwell's equations on the blackboard, next day you'll find most of the students are not returning. So you'll have to introduce the subject to them, to make it interesting to them so that they realize and so I started taking interest in those, but still I didn't know what exactly I'll be doing. And then when I went to TIFR, as I said, I started building this component, the local oscillator system for this radio telescope. And these are all RF and microwave. So I got this hands-on experience of designing something and then seeing that it works. Because another thing that when you are working in a lab, you realize you build something, you design something, you fabricate, build and measure. That gives great, excitement. But at the same time, whenever something works in the very first try, then I think we started thinking that what went wrong, something is wrong. So because nothing really works in the first trial. So you should always, expect that. As a result, then you won't get that much disappointed. Then you actually try to figure out, because one of the main learning process is to figure out what went wrong, what is not working. You learn so much through that, those tracing back. And then from there, when I came to US, to Virginia, I started working very high frequencies. I used to work in meter wavelengths up to about 2 gigahertz. And then I started working at, 500 gigahertz, that is submillimeter wave and terahertz. So that is very high frequency. It works very differently. It's called quasi-optical, somewhere between optics and microwave, mixture of these two. So some of the techniques of optics work in this frequency band. Some of the techniques of the microwave work in this band, and some doesn't work. So you have to know both very well. So I started working on that, and then I did my PhD also in that area. I developed the most sensitive detectors that you can build for radio astronomy, for astrophysics applications, for cosmic microwave background. I actually work on that as well. And I'm also building a lot of instrumentation for planetary science. I had done work for Mars as well. So I'm building a lot of instruments, and one of my role is to come up with new ideas, to think, what we can do, how we can measure, how we can know more about scientific exploration. So that's what I do. That's how this all evolved.
So talking a little bit about more about career opportunities in space science, one of our coordinator, Teshan has some of the questions. So Teshan, you can shoot out the questions.
Thank you, Rupesh. Again, thank you, sir. The introduction you gave was like it's really inspirational, and I mean, like, sometimes I get goosebumps, like, okay, I think I can do this likewise. So thank you for the inspiration. And I would like to ask a question as a student from electronics and communications background. What sort of career opportunities are there in NASA, JPL, or anywhere for a student who has studied in electronics or electrical or some similar background in for bachelor's or master's?
Yeah, it's a very good question. And then, of course, we need a lot of people who have background in electronics communication, because at the end of the day, when you are working in space, you'll have to build instruments, you'll have to build sensors, but you have to read that out. You need electronics to control it, electronics to get the data. You need communication to send the data back. You need antennas, sensors, detectors, then backend processing, signal generation, and then communication and antennas. So you need people from all different backgrounds. It's not only that people who are listening in, it is not just the electronic engineering. We actually have people in NASA at JPL. We have people from all different backgrounds. We need, physicists, we need chemists, we need biologists, because astrobiology is a great thing. If you are, one of the things that we do is trying to look for life on other, outside our planet. And then we need biologists, and then we need astrochemists. So, and we need mechanical engineering, we need thermal engineering, we need architecture, we need writers. At the end of the day, you'll have to, if you discover something, you'll have to disseminate that information to others. So you need all kinds of people with all kinds of background, and that's what we had. So my answer to your question, that study whatever you are studying. Not, that sometimes people say, oh, if I have to go to NASA or ISRO, I have to study aerospace. Not necessarily. Thing is that whatever you are studying, you have to study well. Pay attention to the basics. If you are doing well, if you actually know the basics, then you can actually, when you come and start working, you'll be able to adapt to yourself, because your basics are very strong, right? Your physics, math, chemistry background is strong, and your electronics, whatever you have learned. Because now when you are learning electronics engineering, because you are becoming an expert in that, your expertise is becoming in that, you are studying more. But if you break it down, what you are studying, fundamentally, they are actually the basics, right? The fundamentals of physics, your circuits as well. Think about it, electromagnetics, I always teach electromagnetics from the circuit perspective. If you think about it, you have a wave coming in from free space, and you have an antenna in front. This is a circuit matching problem. Your antenna has certain impedance, your free space impedance in 377 ohm. How do you make sure that there is a good impedance matching between? So you can actually break it down. There is a 377 ohm circuit. There is a antenna impedance circuit that is connecting to a detector that has a different impedance. So how do you match all this stuff? Question becomes that how do you actually do that, come from the electromagnetic side, and then you can actually get involved, and you'll be able to do that. But again, so you can break it down. So it can always break it down some problem into basics, and that's how we solve problem. And we have a lot of undergraduate people working on. We have a lot of people at JPL. They have PhDs, they have masters. So all kind of different level of education people have. So we need everyone. As I said, it needs a village to solve all these problems. So you should study well, whatever you are studying, and then you apply to places like ISRO, apply to places like. Coming to NASA directly from India is a little bit difficult, because how do I know how good or bad you are? Because people are applying from all over the world. Maybe you are applying from, let's say, Raurkela, or someone is applying from Ahmedabad, or someone from Kolkata. But some people are applying from, Frankfurt, Germany. Someone is applying from, Santiago, Chile. someone is applying from Mexico City, and how do I know, you know, who who is better? You can see that the difficulties that we have. So if in that way, it is easier if you have to come and do some higher studies here in the US, then either masters or PhD, then it's easier, right? I will be able to actually, interact. It is not about that Zoom meeting or, WebEx meeting and talking to someone. Uh, if I hopefully in the COVID will go away, so we'll be able to meet people in person, and then interaction that you have in person, that's when you realize that this person matches well with what we need. That's why I always ask people to go for higher studies, and if you do PhD, then it's even better. Again, right now, job market is not going to be very good in near future, because so much of job loss has happened because of COVID-19 all around the globe, and it will take time to recover, right? They'll be hiring, but they'll be hiring people who lost job. So maybe this is a great opportunity to think about higher studies, to think about masters and PhD. And NASA has a great postdoctoral program. After you finish your PhD, you can apply from wherever you are in the globe. I have a lot of, I have postdoctoral fellows with me. I hire people from all over the globe. I have, from France, I have from, Spain, someone just joining in on Tuesday. That person will come in, join in as a new postdoc. He's from Netherlands. I have someone from Nepal. So people coming from all over the globe. So after doing PhD is actually one of the best possible way to come to NASA. Then you can actually come and join as a postdoctoral program. And then it's not easy. Nothing is easy anywhere, whatever you want to do. But you have this opportunity to come. And then if you are doing well, then you get absorbed. So that's how it works.
Right.
Sir, yeah. So Teshan will, before Teshan, you will proceed to your next question. I have a question regarding the COVID situation. So I would like to know, sir, like how the COVID situation has impacted the mission controller or the upcoming missions at NASA, and how's the situation going on in your office, for example?
Oh, yes. So I have not gone to my office or to my lab for the last 6 months. Okay. I'm working from home, like many of us, all around the globe. And we are taking it very, very seriously, because this is a very serious situation. I really want to emphasize, yesterday I read that India had more than 86,000 new cases of COVID-19. That is the highest number of COVID-19 cases single day in the globe. So this situation is really, really bad, and we'll have to take this extremely seriously. And if you don't need to go out, don't go out. And then if you go out, wear mask, maintain physical distancing, hand wash, sanitization, everything is important. So we are taking that seriously. And of course, it is impacting our work. There's no doubt. But, if we are not healthy, if we are not alive, what is work then, right? So you'll have to think about that aspect very well. But it's not that not everyone is not working from home. We have about 20% of people actually going back to lab, because we have assets like a lot of satellites are going around that getting data, and that for them, for their health and maintenance, someone has to go to work. So only few people are going, so that we can maintain the physical distancing. We can have a safe work environment. That is the priority. And so many of us, we are actually working from home, and we interact with people. Some people are going to the lab, not many. And slowly we have opened up so that some people can go. But again, we are making sure that there is only 1 or 2% in the lab. They can actually have space between them. And so they do some measurement, and then we do simulation. So we are using this time, different ways. We are thinking about the next big thing. We are actually, brainstorming about the new ideas, and also doing a lot of simulations. And again, some data analysis. When some data is gathered in the lab, then we are doing it. So like everyone else, our work got impacted. But we'll have to be careful about life and health and safety. That is more important. So I'm sure that we'll come out of it one day. And but if we do the right thing now, we'll be able to come out much stronger and earlier. So that's the, all this, you tell your friends and everyone, you are the ambassador, for in this case, and please tell everyone to stay safe and maintain these, because otherwise things might get out of hand. Then it will be really sad. We'll be losing a lot more people that we need to.
So, like, just regarding the situation of COVID, actually, last year I had worked at, so when I have got to know that some of the missions of ISRO, like the Gaganyaan mission, it has been postponed by a few months due to the COVID situation. So, in NASA also, any particularly some missions are postponed or some deadlines are extended or something like that?
So far, like we had the March 2020 mission that launched on July 30th, right? So we could not postpone that because Mars, there is one challenge is that you every 2 years we have the window of opportunity to launch, because that's when the distance between Mars and Earth are minimum. So in terms of efficiency and fuel, so that's why if we miss that window, then we'll have to wait for 2 years. So as a result, we had to, and we were very close. So we actually, some people, again, maintaining safety and all, they kept working on it. And then good that we were able to launch that. It is on its way to Mars now. It will reach there in February. In that, but others, actually, we are kind of trying to assessing where we are in terms of, and if I say that it won't get impacted, that won't be true, because of course, if people are not working in the lab, we are what we call the touch employees, because you'll have to touch something to make it work, right? So so if you don't touch something, how can you make it work? So for them, if you're not going to the lab, you're not able to touch something, you're not able to work with our hands, then it will something get delayed, of course. But so far we are actually taking stock of the situation, that how things stand, what we can priorities, assigning priority to different tasks. So that's what we are doing. So you have to adapt, you have to be very flexible in your life, that you cannot say, oh, I have to work on this. You said, okay, some of this research work that you are doing, that maybe we'll be able to postpone. But some of the mission critical stuff has to move forward, because there is a lot of money also involved, because if something goes is postponed, it has huge implication on the budget, right? So we are kind of in a safe way trying to see what makes sense, what we should do. So that assessment is going on every day.
So something like there is a 20% attendance or something like that there, and moreover, you are trying to be dependent on simulations and moreover dependent on simulations. Okay,
That's
so
right.
yes, so Teshan has a second question. Teshan, you can shoot up.
Thank you, Rupesh. So my second question for you will be the mode of communication when we are doing a deep space mission, like say that Voyager 1 and 2. So we have been using microwave transmissions all over the time, like in the deep space network. So what will be the futures? I've got to know that there is a field called deep space optical communications, and how is it implemented? Actually, I was in the last year or the year before, I was trying to do a review on that, but it was sort of tough for me. The things were like so complicated. So how will be the future in deep space optical communication?
Yes. So, as you know, that Voyager has gone outside our solar system. So it is amazing that that is the, a man-made object has gone farthest away from our planet. So Voyager, and so it is still sending data back. But again, the data rate is very, very low. It cannot be, it's too far away, not enough power. You cannot have a very big antenna on a system, on a spacecraft. So all these things are actually conspire against you, so that, we are not getting a huge amount of data back, but at least getting this, status, health status of, what is going on, are you still alive? It sends that, okay, I am still here. So that kind of data is coming back. So if you look at Deep Space Network, you all know that Deep Space Network has made three antennas we have in three different locations. One is in California, Goldstone, other one is in Madrid, another one in Australia, so that we can have, their space exactly, located in a way so that we can have 24/7, link to any of the spacecraft. At least one of them will have always link. And most of the current Deep Space Network uses X band, that is about 10 gigahertz range, right? But we have been working on to upgrade that to Ka band, that is about 30 gigahertz. And then, in future, we, as you mentioned, that we are also looking into optical communication, and we actually demonstrated some optical communication. But again, optical communication also has its challenge, because if there is a thick cloud, and then it's not going to go through that, right? So you need a clear line of sight to do that. Also, since the beam that comes from an optical communication, that is very narrow, which means you have to have a very precise the control of whether the receiver can actually receive it very well. So it adds a lot of added complexities as well. Because as you know, the microwave, if there is a small antenna that is actually sending a signal from the spacecraft, the beam that is coming out is very broad. As a result, you do not need to have a very precise alignment to receive that signal. But that is not the case. Think about it. Think about a laser which is actually shining light from a spacecraft. You'll have to catch that. How precise it has to be, because it doesn't expand as much as a microwave signal does. So there are added complexities, but we are looking into that. We are also looking at other kinds, like there is also not only the spacecraft to ground communication, we have spacecraft to spacecraft communication as well. We can have that. I'm a big spacecraft, which is a big antenna. If I can send them data from a smaller spacecraft, which does not have a big antenna, to that one, and then that one can transmit back, it has a clear view, then you can do that optical communication from that. So to do that, since there is no atmosphere in the in outer space, then you can do some very high frequency communication, like terahertz communication you can do, because the data rate is very high. You need a smaller antenna as well, because as the frequency goes up, your antenna can be much smaller, but still you can get same kind of gain in the antenna. So we'll have to look, we are looking into all different kinds of communication, that frequency, in terms of frequency, as well as, of course, we use trying to upgrade to the most modern communication protocols, trying to see what kind of compression you can do. There's a lot of, not only the electronic aspect of it, but also in that area, that how do you compress the data compression, the coding and all those stuff, and different kinds of modulation techniques that you can use. So what can be done? So there's a lot of opportunities in this area. So if as a student, we should all think about communication is a great area, has a lot of potential.
Thank you.
Yeah. Thank you so much, Teshan. So next up, we have some questions from Kushal. So Kushal, are you, can just shoot up the questions?
So firstly, I'd like to really the way you told you were excited for a Monday morning. I used to think, and I still think, that if someone should work, it should be in that way where they are not dreading Monday morning, but they are excited to wake up on a Monday morning. And I'm really happy to get that reassured by someone like you. So my question is, what are like the career opportunities for students who are studying in basic sciences like microbiology, life science, physics, and etc.?
I think it's great. For me personally, I think, one thing is that I find in India, at least, I have Though I am living in the US for all this time, but at heart, if so, I say that you can bring an Indian out of India, but you cannot take the India out of an Indian. Uh, so in that way, I have a lot of, I always think I go back to India very often. I talk to people and try to give my opinion, and maybe they don't care, but I still try. And then, oh, I feel that, if you have in US, at least one thing I really like about it is that suppose you have done undergraduate in one subject, physics, but people, a company will still hire you. In India, suppose a company will be only hiring for some engineering graduates. They say, oh, I need engineering background. But that is not necessarily the case, because if you have studied physics, then you have understood the basics. Maybe you did not do a engineering drawing, so that you cannot really draw that, you used to go with those, T-sets and all, right? But maybe you have not done that, but still your basics are good, so you can pick it up. You can get, if you understand that, you'll be able to understand. So in that way, we'll have to have a good collaboration between the university and the institute and the industry, because the industry needs to realize that what they need is, informed and knowledgeable person, not necessarily just someone has a degree in particular area and that fits well. Because on-job training, if someone can pick up really fast, if you are smart and you have studied physics, you can actually pick up a lot of electronics in no time once you join. That way, all this microbiology, you can see the next, after COVID, you realize the next big thing in the world is the biology and the medicine, in the pharmacy and all these areas, right? We'll have to have therapeutics. And it was there before. It's not that it was not there before. There's so many challenges. Biology is a next big thing, because we still have very less knowledge about how human body works. That is the most complex system that we know. So we can send a rover to Mars, but we cannot create a human being yet. And so much more to learn, and so much research is going on, and we have to, now we know that it's a kind of pandemic situations, and this is not the last one, to be honest, because it will keep happening. And so we need to be prepared. And then what do we need? We need people from all different backgrounds. We need biologists, we need, you said microbiology and all these areas. So again, so there's a lot of opportunities, but again, there has to be a synergy between this industry, academia, because industry should realize that, they need to hire people. Even if someone doesn't have, everyone should not study engineering. Think about it. I actually think that I really like STEM subjects. I like physics, mathematics, I like engineering. But think about it, everyone was Einstein in this world. This is going to be a very boring world. So we need people, someone wants to study music, someone needs to, write poetry and stories as well. So, whatever you are doing, do it well. Not that you'll have to study engineering, you'll have to study science. If you study science engineering, that's good for me, I can hire you. But, but we still need people from all walks of life. I love listening to music. I love reading a good story. So who is going to do that? So we need people so that they can also live their lives. So we'll have to make sure that they also have the opportunity to have a good life. So we'll have to think a holistic approach in this. I know it is not easy. It's very easy for me to say all those stuff, but think about it. To implement something like that, it takes time, it takes effort, it takes a lot of leadership, and I hope it will happen. And my hope is on you all, because you will be the next generation leaders. So you go and change the world.
Thank you so much, sir. Kushal, can you shoot your other question?
Yeah. Sir, I think this might be a question for everyone who's also watching. Why haven't there been any more manned missions from NASA to the moon in the past couple of years? Like we've seen it in the past, in the 1960s, but not, why not now?
Because it costs money. At the end of the day, it's about money. We have in NASA, we have a fixed budget. Has not been going up much. We have our budget is roughly in the order of $20 billion per year, and it is, if you think about it, this is a very small percentage of total budget of the United States government.
Right, right.
And same way, if you talk about ISRO, not only NASA, ISRO is doing very well, right? So ISRO also, we look at ISRO's budget. What is the percentage of the national budget is spent on ISRO. So we'll have to make a priority like that. With the given amount of resources that you have, there are so many things that we want to do. And then and manned missions are very expensive missions, right? So if you actually spend all your money going back to moon, instead, if you actually use some of this money to do something more, something, in other areas as well. So that's what it is always about, how do you balance this out. But again, NASA is planning to do something called, Artemis program,
Right, right.
because that is, that about, this thing, sorry, I have something come up on my screen. So, you know that we have the International Space Station, ISS. So what the Artemis program idea is that what we are planning to do is create a kind of international space stations in moon. So instead of going directly to the moon in future, instead, if you create a ISS, you go there, that is a gateway to moon. If you go there and from there you go and go to the moon, so that will be easier. So also we are inviting a lot of industry to join in, to actually, because a lot of industries are nowadays doing space programs. You have seen SpaceX and many others, Blue Origin and others, they're doing great work. So that is one of the thing that we are doing. So yes, we are going back to moon, but the reason we cannot really have not gone back with manned missions is, is about all these constraints that we have.
Some robotic missions have been there, like sending the robots to the moon.
That's right.
So next up we have Ekta with us. Ekta, am I audible to you? Are you here?
Yes, you are
So
audible.
Ekta, you can.
First of all, sir, I would like to thank you for such a motivating speech till now. And I have heard a lot about you, and now I know what it takes to be in NASA. The humility you have, the diversity for various occupations, and also the kind of passion you endure for the kind of work you are pursuing. So my question to you is, what are the career opportunities for chemical engineering students in NASA? Basically, I want to know, like, do you use subjects like heat transfer, mass transfer, and like?
Oh, absolutely. As I said, we need people from all different fields. Chemical engineering is one of them. We have chemical engineers on our lab. One of the things, chemical and biochemistry is also important. You said about heat transfer and all.
Hmm.
Thermal is one of the most important aspects of any space missions.
Any operation, yes, sir.
Because it goes through all these. You have to create a thermal engineers. When I do my budget for for my instrument budget I'm doing, we'll have to keep a lot of money aside for thermal, because I need to get a good thermal engineer who will look into aspect of that. Electronics generate heat, right? So how do you take that heat out? And in a vacuum environment, there is no convection is happening.
True.
So you cannot really just put a fan and take the heat out. What is the fan going to do? Right? So think about it. All the problem that we solve on Earth, sitting here in one way, in a computer that you are using right now, there's a fan going around trying to keep your, the CPU cool. That I cannot do. So we need to have a very good thermal engineering to make sure that we take the heat out and then they dissipate the heat somehow. And also sometimes you need to maintain the temperature. Some of these things times we use cryogenic temperatures, low temperatures. So that is very important. So as I said, chemical engineering not only does that, I have friends who have done chemical engineering, but they are currently working on, planetary protection. Because see, when we are trying to look for life on Mars, we are sending a spacecraft. we'll have to make sure that we don't carry life from here and then discover that there, right? So that will be sad. We'll have to protect. That's called planetary protection. We take that very, very seriously. And how do you protect it? So we'll have to scrub our spacecraft before it's launched. There'll be biologists, there'll be chemists and chemical engineers. They are saying, okay, you actually clean these surfaces this way. Nowadays, we know very well about cleaning surfaces because of COVID-19.
Right.
So
Yeah.
that we have been doing all the time to our spacecraft to make sure that we kill all these biological materials or the germs on our spacecraft, so that when we go there, we are going in a sterile, spacecraft, and we're not carrying any form of life. Because if we do that, that will be sad, that we take something and it starts there. Then if we discover that is not real discovery.
True.
So that's why you really need, these people of this kind of background.
Diversity of professions. Yes, sir. Thank you. And the second question I have is, what type of propulsions can we expect in future?
Okay, very good again. So we know that we are doing chemical propulsion nowadays, but there's a lot work has been done on electric propulsion. We are really
And
looking at
nuclear ones?
electric, not nuclear. The
Not yet.
electric propulsion,
Okay.
not nuclear. This electric propulsion is more about electrical based systems. So there we are finding that they are efficient, and also idea is, can we use electrical propulsion to go faster, and because it takes time to reach, right? So nuclear propulsion thing is difficult, and we'll have to make sure it's safe. That
Yes.
whenever nuclear always has to, the safety becomes, think about, things can go wrong, and if it does, and it might cause a huge disaster. So we'll have to be really, really careful about thinking about nuclear propulsion. But electrical propulsion has made a lot of progress. We have been really looking into electrical propulsion. There is a big, you can see it says Jet Propulsion Laboratory. So we have a lot of people who are working on propulsion systems, and I know with some of them they're working on electric propulsion, and a lot of progress has been made. I think you'll see more and more electrical propulsion coming up in many of the future missions.
Okay, sir.
Thank you, sir.
Thank you so much, Ekta. So, sir, let me just read some of the chats that we have. So, someone is asking that what are the, as you already told, so what are the career opportunities for students in pursuing their master's, PhD, or undergrad in computer science? So, like you mentioned that some data acquisition.
That computer science was very important. So all aspects. People will ask me computer science, and then electrical engineering, electronic engineering, aerospace engineering. I think I answered already that opportunities there for everyone, not only for NASA, for ISRO as well, and all other space organizations. So if you are interested about space science and technology, so again, basic thing I keep repeating. I'm sorry, I'm kind of a broken record, that it doesn't matter what you are studying, you have to study well. That has been my motto in life, that whatever you do, it's not about studying. Whatever you do, try to be the best in that. I do all kinds of stuff. I cook, I wash dishes, I clean home. Whenever I'm washing dishes, I always try to be the best dishwasher in the world. So next time you are looking for someone to wash your dish, if you hire me, I don't think you'll be disappointed. So that has been, that's my attitude always in life, that whatever I do, I try to do in the best of my ability. If you have that attitude, then it doesn't matter. Because people will see that you are actually giving your 100%, and so that, make that as your motto of life. I'm saying that you should become a dishwasher, but you should do dishwasher at home, help others.
That's really interesting. So one thing that I found, that I've been reading about and I found interesting, is that while you were doing your PhD from Caltech, and after graduating from Caltech, you must have got offers from some MNCs and companies from Silicon Valley and all. So why did you choose NASA? That I have an intuition that the job at NASA is relatively lesser than those MNCs. So what was your goal at that time, and what was your thinking in that?
Yeah, it's true that actually when I was graduating, I actually got a call. I got calls and got some, people from these companies to work there. And then uh, the salaries that they offer is almost twice as what I was offered at NASA. But I did not have any doubts. I did not really think twice. Because for me, it's, of course everyone has their own way of looking at things. I did not have money when I was growing up, as I said. That's why, in a very strange way, that I didn't really don't care as much about money. It should be the opposite way, right? But
Yeah,
I don't
exactly, sir.
Mm,
know
exactly.
why. Because I think whatever I have, whatever I earn, is much more than what I need, to be honest. So for me, that work, this what I'm doing is much more important. I am the happiest person. You can see, maybe if I don't know whether you can realize looking at me,
We
that
can
I'm
Yes,
very
realize.
so we can
happy.
realize that
We
exactly.
can
I
realize.
am really a happy person because,
Yeah.
if you are working on something that you like, what more you want? And of course, they're on top of that, they're paying me.
Yes.
So that itself is a great thing. So that's why I actually, there is no really question. Even now, I actually get calls from some organizations, and the kind of numbers they tell me is that they said that if you work in our organization for 2 to 3 years, you won't have to work again in your life. Uh, then what do I do? So that's so that's why I actually do not go there. I am really enjoying working with my colleagues. They are the best in the world. People who I'm surrounded by. I always give an advice to everyone, to all of you also. If you want to be successful in life, surround yourself with people who are smarter than you. That's it. That is the key to success.
Yes, sir. So that was really insightful. So, sir, I'd like to talk a little bit about the science education part. So, actually, as you mentioned about Professor Nallikar, I myself in my first year, I got an opportunity to work with Professor H.C. Verma, and he was like one of the leading professor. We like in our 11th and 12th, we literally worshipped him. I got an opportunity to work under him. So, one important thing that he told me, apart from research, is that whenever you are doing research, it is your responsibility to work in science education also. And I think that is what you have been doing. Like yesterday only, you were having a webinar, and you told that you get offers for webinar and a lot of time. So what would you like to tell about it, the science education part with research?
So exactly, we have a lot of responsibility. All of us have a lot of responsibility to make sure that whatever we learn, in India, when I grew up, it was very cheap. College I went was almost free, right? So I got almost a free education in India from my college. You know how much I used to pay per year? Our fee was, including hostel fee, was 112 rupees per year, something like that. So this, I mean, unbelievable. Now it has, I know
Exactly.
that it has gone
Now it
up,
has
and
more two zeros with.
yeah, but still, so it is our responsibility to make sure that what we learn, that disseminate the information that we have, talk to people. So education, science education is important, and particularly in today's day and age, because on the internet, if you go, you will find so much of fake information out there. So, and I don't know why, what motivates people to actually propagate that kind of false narrative about a lot of things. If you go there, go to YouTube, you will find, so much of, disinformation. So that's why it is very much more important for all of us to actually think in terms of scientific way for everyday life, think scientific way and ask these questions. I always tell that all of us are scientists. Everyone is a scientist. And then said that why, how come? Suppose you are cooking something in your kitchen, and you are actually cooking scientist, because you are the one, you are figuring it out, what works better, how it works, when to put what kind of spices, and how much to put. That is an experiment that you are
Yeah,
doing. You are
exactly.
doing a chemical, physics, all kinds of experiment. The thermal, you lower the heat down at certain point of time during cooking, and then you turn the heat up. That is thermal engineering you are doing. So all kinds of stuff that we do in our daily life, because we are trying to do how things work. What is science? Science is to figure it out. We are actually like detectives. We are the truth finder. We are trying to find out truth behind something, right? We are trying to find out how things work. That is the mission of a scientist. And that is the mission of everyday life for everyone. So our role is to make sure that we actually think in terms of scientific way. And when we see something, I have this request to all of you, whoever is listening, and I don't know how many people are listening in, but my request to all of you is that when you get a WhatsApp something, before clicking the forward, please do your due diligence. Please go and try to, information is there. Do a Google, you'll be able to find out if it is true or if it is fake. A lot of times I get things and I actually then send to people, then request everyone that, what is this urge of forward immediately without really checking? So what do you gain out of just because that people who are sending the disinformation, that is the way the success they use us. We become the vehicle of disinformation if we do that, right? If we forward without checking. So next time you get anything you get, and just wait, do a little bit of checking, and if you have doubt, don't forward. Because if you do not forward something, not that your TRP will go down. So it's not about that, it will be fine. So just do it. That is our role. Our role as a human being, our role as in the civic society is to make sure that we think in terms of science. That is one aspect of it. And another aspect of it, that I got this great opportunity. I've been one of the lucky person that I am actually working in these places. And if I go and talk to you, if I can inspire one person to actually do something beyond them and do something good, that will be the ultimate reward for me. So I got many awards and everything, but those are pale in comparison when I actually hear from someone that I actually get email from sometimes, some text from some people. They said that, I heard you talk about something, and since then I decided to do my PhD, and I did my PhD. I'm working here, and I thank you. I feel so elated, because that is the ultimate reward that I can get. So it is all of duty of all of us to make sure that actually we give back to, because we got so much.
Next question I'd like to ask, it is moreover personal regarding the work of research. So actually last year I was working at ISRO during the Chandrayaan 2 mission. And during the same time, I got to attend a lecture by Professor William Bielek from University of Princeton. And he told me, after the lecture, he told me lots of things regarding how to improve the quality of work that you, like you told earlier, like that we develop a kind of tunnel vision sometimes. So he told me certain things and I tried to apply it. Like I used to, after he told me, actually I used to manage to sleep by around 11 o'clock in the night, closing all my research work and waking up at around 5:30 a.m. And I switching off my internet and just going through all the papers that I read in last 1 week, and not just for the paper, for the purpose of research, just for appreciating the work that was there in the research. And after that, I went through the data I have collected from the lab in the ISRO. I just went through it, and then I go to the simulator and I did some simulations. No, I just matched up with the calibration just to play with it. So he told me that by doing this, we resonate a lot with our research and we internalize our research. So somehow the quality of our research is like more developed, and this tunneling is more, we can get out of tunneling and we become one with the research. So what are your, like you told about you have coffee with your colleagues. So what are the things that you personally practice to improve the quality of your research yourself?
Yeah, so in the research world is very different, but you cannot go to your lab or to your office and say, today I'm going to innovate something. Today I'm going to discover something. Unfortunately, it does not work that way, right? It is a hard work. It is a long process. So you will find that most of my time in my office, when I used to go to office 6 months ago earlier. We go to my office. Most of my time actually spent talking to people and on the whiteboard. So people's stream of my colleagues, my postdocs and others keep coming, and because we are trying to solve problems, right? And then we start discussing, and it goes, the beauty of research is that it does not always go in the straight line. It goes all the different ways, and we started talking about one thing and land up discussing completely different aspect of something else. And then that's what that does, actually, that actually you start thinking about it, that okay. And when they leave, I have a little bit of time to think about myself, sit down, and I then think, okay, you were talking about this, maybe for some other completely different area of research, then maybe I can actually apply some of these and get an idea and start working on that. So, for different people, it works very different way, of course. But for me, I am finding that, of course, you need your time to think, clear your head and start thinking about it. But at the same time, most of my thinking happens during I'm talking to someone, because they said something in one area. I'm thinking, can I use to solve my other problem? That maybe there's a new idea that came in. So that's how it works. And also, again, there is no unique solution for this. Don't think that my way is the one that you should practice. Whatever works for you, that you should do that. And again, one thing I'll tell in this respect, because you mentioned about going to bed or time and all, take care of your health. Because if you do not take care of your health, you won't be able to do good research. It's very, very important to have a good, healthy body and mind, right? So that is important that is not only for research, for everything else. So exercise, watch what you are eating. You might, I know I'm sounding like a kind of
No, sir, it's
person giving, all kinds of, advices, but it's very important, because take care of your health. Don't get into, all these, at a young age, you should not be obese. You should not start, having these different health issues, because then that actually takes a lot of energy out of you, right? So I every 5 days a week, I actually run. In the morning, I wake up around before 5, and then I go run about 8 kilometers, 8 to 10 kilometers a day for 5 days a week. And then I come back, and now I'm at home, right? So try to eat well and try to have a good, healthy living, style. Get enough sleep. Sleep is important. You see that, we know that during the exams, you all, do all-nighter. That's fine. We used to do that too. But normal times, try to get enough sleep. That is important. All this aspect of it. Research, you said that you just work something, solve some equation, that's how you become a great researcher. No, you'll have to pay really attention, because you think better. If you eat well, if you have healthy living, then you are thinking better, right? And you have to be a happy person as well. So all this is as I said, is a big mix of things.
Yeah, yes. That perfectly makes sense. So next thing I would like to ask or mention is, last time we had a webinar by one of the co-founder of SpaceX, Mr. Jim Kent, and he had worked. He initially started the SpaceX with Elon Musk, and he told a lot of things. And one of the things that I found interesting, what he told was there was some kind of insurance policy with spacecrafts and satellites also, like the way we have with our cars and all these vehicles. So there is something called some sort of insurance policy also with the spacecrafts that go into the orbit and the satellites. So can you tell a little bit about it?
Those things are of course, that we are spending so much money, right? And things might go wrong, right? And that is for SpaceX and others is more important. They are trying to, at the end of the day, they are aim also make money,
Yeah,
right?
private money.
This is private money. For us, we are spending public fund, so we have to be more careful.
Yes, yes.
We have to be more careful, because when taxpayers' money is being spent, our responsibility is to make sure that we don't waste it. because I'm spending, NASA is spending my money in a way, because I pay taxes, and that's how that money comes back here. So our responsibilities are in that way, we make sure. But again, sometimes some of these insurance is done to, protect us against, some of these losses that can occur. But again, this is very different for SpaceX than NASA or ISRO.
Sir, another thing is we talk a lot about space debris. So last 6 months or so, I've been working with a startup who works with who has the aim of cleaning, or at least developing a mechanism to analyze the presence of debris in the space. And especially, as you know, the smaller debris is not easy to track. So there have been attempts by the countries to destroy the non-functional satellites. Like recently, we had in India also we had an anti-satellite mission that created a lot of buzz. In fact, NASA also criticized it. So, what do you think is the role of responsibility of the nation as a whole, of nations as a whole, in cleaning the debris? Like how they should address it exactly?
This is actually the big problem, because space debris, if you think about it, because what happens that you send a satellite and it has some finite lifetime, right? And after that, when it becomes inoperational, it becomes junk, space junk. But those are big space junks are at least in a way easy to track, easier to avoid. Major challenge is that when the small debris, because they start disintegrating and then starts creating small particles. And then if you think about it, in a very small size particle traveling at a very high speed, that can do a huge amount of damage to your spacecraft. And that keeps on happening, because something, just think about it, a nut or a bolt gets removed from some spacecraft, and that becomes a huge kind of a bullet
Yeah.
going traveling as those speeds. So it is a big challenge. And then NASA has been thinking about it, and other space agencies also thinking about it. But again, you'll have to be very careful about some of the technology that you develop that can kind of cleaning up that, the kind of destroying some stuff, but in the process intentionally you can destroy someone else's satellite, right?
Yeah.
So where do you draw the line? So all these stuff are important, and that can be solved in a international in a way. You'll have to do, all the space agencies has to work together, because we are all of us are together in this. Because I cannot launch my satellite if there is no area to go through.
Yeah.
Right? If the entire sky is filled with all these other spacecraft or junk space debris, how do I launch my spacecraft? So it is true for everyone. So we'll have to find a way. We'll have to find a way to track. There are a lot of technologies we are developing. Like I have been thinking, using some radar, very terahertz radar, very high frequency radar, where you can actually track very small particle, millimeter size particles as well. But tracking is one thing, and the second thing, how to clean it, right? But again, it costs money, right? So all the space agencies have to come together and keep aside some funds to address this. No nation can do it alone, because you know that UAE also sent a mission to Mars now recently, just before we did. So everyone in together. You cannot say that, oh, I don't care, I'm not sending too many of these, so I don't care. It is not that. Everyone has to come together and come up with some ideas what you can do. It's not an easy problem to solve, to be honest.
So do you expect UN to interfere in this? Do you expect UN interference for this?
I don't know whether UN will be able to come and do something. I don't know. Maybe if they do, but it always works better if the space agencies talk to themselves instead of some third party coming and telling you what to do. Instead, if NASA, ESA, ISRO, JAXA, and Korean space agencies, UAE space agency, all of them, they get together saying that we are having this problem. So let's
Sir, but
solve it.
financially, all have to allocate some budget for it, and
Yeah.
they won't do it just on moral
But
basis.
UN
They
is
need
not
some
going to,
kind of
but UN is not going to give money as well, right? UN is
yeah, but
not a funding organization.
at least a reinforcement to do a particular
Yeah, like it's a
budget
collective effort or something.
allocation.
Yeah,
Exactly, Rupesh is saying.
Yeah.
that's right. So somehow we'll have to, if UN can bring everyone together, it's great. But my thinking is that, that if these agencies has to talk to themselves, and I think they are aware of this, to be, fair, that they are very much aware of all these agencies, and they are talking to themselves. So I'm hopeful. I'm a very optimistic person, so I'm very hopeful that it will happen. But these challenges are daunting,
Big.
because first you have to identify them, track them, then clean them up. So there are a lot of ideas, there's some suction system and all, so that you can do that. But it's not easy problem to solve.
Okay, sir. Thank you so much, sir. So last few questions that we have here is this is a really common question that people have asked me myself and some of my juniors and my seniors and my classmates. So it is like why some of the scientists and professors they do not reply to the mails like regarding internship or research projects or some genuine right. So what is your take about it? Like because according to my experience, the people I have wrote a mail, they have efficiently replied. Like in my first year, I worked with something related to black holes, and I wrote a mail to Professor Rana Digari. He's a big name you must have. He's a fundamental physics prize. He won, and he did reply. And I wrote to Professor Etziorma, they replied. I wrote to ISRO, they replied. I wrote to you, you replied. So, what do you think is the thing with the people not replying to the mails and reject? Like
Uh,
rejection is a better option. Yeah.
So people who are actually complaining, I can feel for them, but at the same time, sometimes they should put themselves in the shoe of the other
Yeah,
person
exactly.
on the other
He
side.
might be busy.
I get email at LinkedIn and all. There are hundreds of those email come every day,
Yeah.
and if I sit down and start replying to all of them, that's all will be my 24/7 job, right? So
Yes.
I'll have to sometimes think about which one I can or I cannot reply. It is not that I don't want to reply, and not that they don't want to reply. They'll be more than happy to reply, but it keeps coming, and sometimes it's a lot of things is very in a frivolous way, because I'll give an example. I won't name the institution from India. I got an email saying that that person has read of one of my papers that was in terahertz in a technology area in electronic engineering. So they actually wrote the name of the title of the paper and everything. They wrote my paper and found it really interesting and wants to come and work with me as an intern. And that person is a civil engineering student and from one of the IITs. And thing is that what they have done is they have created a kind of an AI or some kind of tool. They actually search for all this and search for the name and the title of the papers and send this email to
Without
everyone.
actually reading the paper.
Yeah, because a civil engineer won't read the
Yeah,
paper
exactly.
that this person mentioned. There is
Yeah.
absolutely nothing to do with any of this. So, but in this case, at least it was obvious that what is going on. So, that institute, I have my classmate who did undergraduate with me. He is the one of the professors in the same department. So,
Okay.
so I actually wrote to my
Forwarded the mail.
I wrote to my friend saying that, don't penalize this student, but please talk to them. And what that does, that actually harms other students. That harms other legitimate students, because then I'll be very skeptical of, responding to someone who just, they're not really reading. They're just writing, I want to do internship and all. So again, you cannot just come and do an internship in NASA. They say also, sometimes I write to them, they said, oh, I can do only, my classes in the summertime is only about these many weeks, but NASA has a fixed number of days that you have to do internship when you come to do internship. So they say, I cannot do, can you give me internship for 1 month? Can you give me internship for 15 days? I cannot do. NASA has a very fixed way of doing internships that they open up their website at certain day of the year. You go in there, you apply there. I keep writing the same thing to again and again. So I urge everyone to actually do your homework. Go to a NASA website, read what are the things. Instead of writing an email to someone in the very first time and asking those questions, instead do your diligence and find out what are those things. Then your chances of getting a reply will be higher. If you are really, trying to ask a very specific question. And then again, I cannot hire a lot of interns. And if the interns are coming from within the US, it is easier for me to actually take them because there are other expenses associated with someone coming from outside. And also there is a lot of, IETE issues, international issues are there as well. So there is a lot of, there are a lot of, barriers. It's not that I don't want to respond. I actually try to respond to a lot of people. I do. I make sure that I do. But sometimes I apologize again if I have not responded to your, text, email, or anything. But I try my best to do that. But again, it is not easy. Sometimes you do not get a response, not because they don't want to, but because they are busy as well.
Yes.
Sir, I have a little question. Only few countries in the world that has ability to send a rocket to the space, but there are many countries that do not have that ability. So, what can those countries do to contribute to the development of this space industry?
For context, Tishan is from Sri Lanka. He's in Sri Lanka right now.
Yeah, I saw his last name. I know from that is from Sri Lanka. And actually, I have a very good friend. They're from Sri Lanka. My daughter's good friend from Sri Lanka. I call him my long lost brother. And then also I have been asked to go to Sri Lanka, but it did not happen. I have not been to Sri Lanka yet. I am looking forward to go to Sri Lanka one of these days. And people can actually contribute. So there is a lot of programs. Even in NASA, ISRO also has this kind of program that you can actually build from time to time. These calls go out. You can build something. Like one of the things you can do is build some CubeSats. CubeSats are very small satellites, shoebox satellite you can do, and then you can launch those along with when NASA launches some satellites. Same with ISRO. ISRO has been actually launching satellites for other countries. So you do not need to have a launch vehicle, but if you have a space program and you want to do some science or you want to do some experiments, you can build those and then contact and see NASA, ISRO, or ESA, those agencies, and you'll be able to do some your experiments. So that will be the way to develop the space program in places like Sri Lanka and Bangladesh. I think this is a great opportunity. And again, you have to invest. Those countries have to invest in those colleges, those universities, and those institutes where they can build these things, and then contact NASA, ISRO, and other places, and then launch and get the data.
Thank you.
Okay, sir. Thank you so much. So it was a really nice session. I think most of our questions are covered. So what would be, I'd like to know what would be your final words for someone who is just a space enthusiast, or maybe in his undergrad or postgrad. So what are your final words for students like that?
Yeah, to all the students, again, I'll start with what I started with at the beginning, that stay safe. Because this is a very, very difficult time for all of us all around the globe. So, maintain, you are the one who can stop this virus. All of us individually, that's what we need to do. So do not go out if you don't need to go out, and wear a mask whenever you are going out. Do wash your hand, clean, and use sanitizers. Those, I'll start with that. And again, whatever you are doing, be passionate about it, and do things that you have passion about. I know that there are a lot of family pressure comes on us, all of you. Maybe you wanted to become a musician, but you were studying electronic engineering. It is very highly possible that, but don't give up on your passion. Because once you are doing something that you are passionate about, that's when you contribute most. That's because your heart is to that. So try to do that. I know, some generation still here who doesn't have an option. That you have to, work in an area where you can get a job because of financial situation. But if your financial situation is not that dire, then you'll be able to actually, at least, someone has your back in that they say, so that you can pursue something. And do not get bogged down by failure, because though in NASA we have the motto is failure is not an option, because we cannot go back and fix it. But in life we fail all the time, right? We fail every single day. There is something or the other we're failing. But key is that, are we learning something from that failure, right? So I always tell people, like one example I give, you notice that when there is a crash, aircraft or something crashes, there is an organization in US called NTSB, National Transportation Safety Board. What they do is actually they piece together. You have seen that actually they collect each and every debris of that plane and then put it together and try to find out what went wrong. They went meticulously about this, and most often they actually figured out what happened and why did it crash. Then they do recommendation that what can be done in future. This is very important. That is very important for all of us, because when you do fail, of course, you have give yourself 24 hours to brood over it, cry, feel sad, feel down. That is needed. Talk to your friend, find a friend who can actually a shoulder to cry on, because friends are very, very important in that. Talk to people. Do not just do it by yourself. Do not get depressed. Depression will come. Depression is very, very dangerous. I mean, college campuses, this happens. Please do not think about suicide and all those, because that is not the solution. Try to find out what happened. Give yourself 24 hours. That's what I do. Give yourself 24 hours, but after 24 hours, sit down, start thinking what happened, why, where you went wrong, what can you do better. If you analyze yourself step by step, going back, what exactly went wrong, then you learn so much, because then you actually learn something from it, that that I'll have to do better in this area. I'll have to do. I should not repeat what I have done. I give you an example. See, talking to public is not easy. Public speaking is, you all know. There is something called a Seinfeld. Many of you must have watched a comedy show, Seinfeld. There, Jerry Seinfeld had said one thing, that when you are giving a eulogy at someone's, someone has died, you give a eulogy. The most, even from death, people fear is our public speaking, because instead of giving the eulogy, you rather be in that casket, because that's what. But again, so I have been doing these webinars, because in this platform it is very different. You are interacting with people in a very different way. So when I give this, I'm talking to you guys, and I go back and start thinking that, okay, what I could have done better. Because that every opportunity is a learning opportunity, right? That can I do something better? Can I, tell you guys something that I could have done in a better way? So this is how we should think about. And I will end with one thing that my mother had told me, and that I think it's very important in my life, and I actually try to follow it. That you can be the most, greatest, you can achieve a lot of things in your life, everything, but be a good human being. Because be passionate, be, empathy is important. Think about others. If you can help others, that is very, very important. So try to be a good human being. At the end of the day, all this stuff, accolades and everything that people get, all the money that you make is not really that valuable. If the pleasure that you get, seeing a smile on someone else's face, that's the most important thing in life. And also my mother has said that, when I joined NASA, she said that, she of course told me in Bengali, I'll say that in Bengali, then I'll translate. She said that, আকাশকে ছুতে চাও খুব ভালো, কিন্তু পা যেন মাটিতে থাকে. It means that you are trying to touch the sky. It's great, but keep your feet on the ground. And I try to do that. And you know that maybe grounding is very important for electrical engineers. You know that as well, right?
Right.
So
Definitely.
I try to practice that in my life. So I don't know how successful I have been, but I'm trying that. That is still ongoing. So with that, I'll end, and thank you so much for giving me this opportunity to talk to you all. I love talking to people and sharing my experiences. Thank you.
Thank you. Thank you. Thank you
Thank
so
you,
much,
sir.
sir.
So much.
Thank you,
It's
sir.
more than privilege to have your presence with us. And thank you so much to everyone for attending our session. And that's it. And thank you so much, guys.
Okay,
Goodbye,
bye.
sir.
Good night to
Bye.
you all if you're in India. It's morning here. It's about
Yes, sir.
9:30 a.m.
Okay.
So my day will start. So
sir.
again, thank you.
Okay, sir.
Thank you, sir.
Have a nice day, sir.
Bye.
Goodbye, sir.